Good morning. It's still very early, so I'm not gonna be very loud. So a little bit of whispering. It's 7:20 a.m. Alright, so I tried to solve this yesterday, so that took a whole hour. And then last night I finally, like around midnight, I finally got it to work. So this was from 8 hours ago. So this entire thing took around 1 hour, 15 or 20 minutes, I think. So I just want to make another video here so I can explain my solution, and then we can do the time and space analysis, and then we will also take a look at top solutions. People don't like this problem so much, which I mean, this is a really hard problem. So I'm just so happy that I actually managed to make it work in the end. I'm pretty sure there are way smarter solutions than this. Alright, let's go over it. So this is the function. What's it called? It doesn't show. Okay, but this is the function that you're given with and you're supposed to write, and this is the additional function that I'm using called rearrange. So we have this result, which is gonna be a list of strings. For each line, I'm trying to build each line. So this will be a list of words, so also a list of strings, since each word is a string. So that's for each line. And we have this count to help us with all the white spaces. Okay, so we wanna go over all the words, and we also need this index. So for I in range, first we get which word it is. So let's take the first one as an example. So first word is this. This has 4 characters, so count is starting from 0, then plus 4. That is not exceeding the max width of 16. So we are gonna put this word in the list. So we are storing all the words for each line, and then we're gonna rearrange that line separately. Okay, so we store this in this line list, and it is not the last word of this entire words list yet. So we just go in here, we store that, and we increment count by the length of this word plus 1, which is the white space that needs to come after this word, because we need at least 1 white space between the words for each line. So that's the minimum. So what we're counting here is the minimum amount of spaces that's gonna be used for that line, and we're gonna do this until we see, oh, okay, there's no more space. Then we need to go to the next line and rearrange this line we just finished. Okay, so for this word, we're doing this. If we're not going in here and we're not going here, then we have the next word is same situation. We go in this if, we append is to line, so now line has 2 words, this is, and then we are adding another. So 4 plus 1, 5, plus 2, 7, plus 1, 8. So right now count is at 8. And we do the same thing again for n. So now count is at 11. And our max width is 16. So we have counted 11 currently. Next word is example. So example has 7 letters. So we had 11. 11 plus 7 will exceed 16. So we're going here. So result, that's the final result. We want to append this rearrange function. Will give us a string. So we want to append that string to our final result. Let's go and look at rearrange. So it takes this line, which is the previous line that we were just using, which has this is n, 3 letters in there. A list of 3 words, sorry. So this is a list of 3 words. Max width is 16. Count minus 1. So count is currently counting this plus 1 white space. This is plus 1 white space, and then n plus 1 white space. So we're just removing 1 from it, which will give us exactly how many spaces it takes to have. This is n with only 1 white space in between, so that would be the minimum amount of spaces these words need for that line. Okay, so we go in here, we have this line, we have max width, and we have the minimum number of spaces need for those words with 1 white space in between. So this is to handle the situation where there's only 1 word. So let's look at that later. So return, we're returning a string, so we're gonna build this string. Start with empty string. Now, what's the number of total white spaces? That's what we're calculating here. Max width minus, so count is this with only 1 white space in between, and the number of white spaces in between are simply the number of words in this list minus 1. So length of line minus 1. That will be the amount of white spaces that's in between, and if we use count minus that, we will be getting exactly the white spaces that the words are using without the in-between white spaces. So that is what's in here. So this is simply this is the entire, this is the number of characters in this list. We could actually just count that here instead of using this little calculation, but I thought that was additional unnecessary calculation since this is already ready. This is ready, and I thought this would be a little bit more efficient. It's probably not gonna make the most difference. Alright, so this is the number of white spaces in total that we want to add between all these words. So now what's the minimum amount of white spaces that's gonna be in between all the words? So say if we had 8 white spaces and we have 3 words, that means we need at least 4 white spaces between words. And say if we had 10 white spaces and 3 words, then we will be doing 10 divided by 2. We will still have 4 minimum white spaces between, but we will have a remainder of 2, which no, oh my god, sorry, that's a horrible example. Okay. Oh, 1 sec, let me turn this off. Okay, so between is using the total amount of white spaces divided by the number of, so this is again the number of words in this line minus 1, because we don't need white space after the last word. So if there are 3 words, we only need to calculate 2 in between white spaces. So that will give us the minimum number of white spaces. And if we had remainder from this, so this needs to be an integer, otherwise it will return as a float. So if we had remainder, let's say, so in this case, we had 4 and 4. Yeah, that's why I was using 8. And what if we had 9? So 10 doesn't work because then would just be 5 and 5. So if we had 9, and then it will give us between 4 and remainder 1, which means starting from the left, because this is one of the condition. So if we have remainder, then we wanna add 1 extra white space padding starting from the left. So if we had so here we have 4 words. Let's say between will be 2 and remainder 2. That means it will be 2 white spaces between each of these words, and we want to add 1 extra white space padding to the first 2 in between. So here and here we will be having 2 plus 1 padding starting from the left. Okay. So I have explained this part. Now we wanna start constructing this string with the words and the padding. So line is all the words in this line. So for all the words in this line, we are doing this until the second to last, because the last one doesn't have padding, so we're just gonna add that in the end. So this is gonna iterate from the first word until the second to the last word. So for each of them, we're adding the word, we're adding the amount of in between white spaces, and if we have remainder, then that means we're adding an extra white space, just one extra. So if we had remainder 2, we'll be adding after the first word, we add 1 and we decrement remainder. Then after the second word, we add 1 again, we decrement, now remainder is 0, so it won't be adding more. So this will construct this string that we need, and we adding the last word to the end. So this will return that string, and we're gonna append that to the result, which is a list of these strings. So then what we're doing here is we are done with this previous line, and we want to now start with the next line. So the word is actually at example, because that's where we realized, oh okay, example cannot fill in the previous line, so that's where we stopped and rearranged the previous line. So now we are starting with the next line. We are resetting count to the length of this first word example plus 1 for white space, and the line is now a new empty string starting with the line is gonna be a list. So this list now has 1 element, which is the current word, and then it will go over again to append the next word. So next round we have count, which is example 7 plus 1, count is 8. Line has 1 word, which is example, so off will be going in here again, appending to the line list, incrementing count, and then text, same thing. And then last one, let's do the last one. So now we're at word justification with this period. So this is together as a string. So word is that. We're also at the last index. So we see that it will exceed max width, so we're going in here. So this will take care of this line and put that into the result. Now we reset content line. Okay. So we are at the last one. So we are going in here. And what do we do here? Since we have this for the last line, it should just be left justified, no extra spaces inserted between words. Then we simply leave it as it is and add padding to the right, which is what we're doing here. So we have this line, which is simply just the current. Okay, so in this case it's just one word, but let's see if it's this case. Okay, that'll be a better example. So when we're at shall, when the word is at shall, we will go in here, do this line, rearrange, and then reset count to be the length of shall plus 1, and line is now having this one element of shall. So it's not the last, so it doesn't go here yet. And then we have B. Okay, so that is still not exceeding max width, so we are appending this. Line has shall be, and count has shall be plus the one white space here and one white space here. So it is the last word. So line has these two words without the white spaces, because it's just a list of words. So we want to join them with white spaces. That will give us shall white space B. And now this function is gonna add all the padding we need to the right. So the entire length will be this max width. And we're adding white spaces. So that's what it does. So this part gives us shall white space B in a string, I believe, and then we pad white spaces to the right. So in total we still have this max width. So this is the final string. We append that to result and we return. Well, actually we don't need return result there, so we're gonna return here because this is the last word anyways. Okay, so the only thing I haven't talked about is this one. So this will be a good example for that as well. So when we are at word shall, we're gonna go in this rearrange function, and the line will only have one word, which is acknowledgement. So line only has one length 1. Why do we need to do this separately? It's because this is being divided, so if we don't handle this, this will be dividing 0, so give us an divide by 0 error. So when this is only just one word, we don't need any rearranging. All we need is to put that word there and add the padding to the right like we're doing here. So we're just taking that one word, adding padding to the right, and make sure it's got total max width. So that's what we're returning as that string. Okay, So that's, oh, I can't believe it took 20 minutes to explain and go over. Let's see if it works. Yes, okay. So it is very efficient. I believe. So there it is. That's my solution. I'm sure there are smarter solutions. So for this solution, let's see, what's the time and space for this solution? So we are going over each words, then we are storing them in a list, we are rearranging. Okay, so this is linear. So this for loop is linear because we're going over each word, we're storing them in the list, we're going one by one. So that's linear. Now for each line we have this rearrange function, which is also linear because rearrange is gonna take every word in the line and just add padding to it. So the algorithm goes like, okay, it goes through these and then it's gonna go rearrange this. So essentially it's linear, but it's traversing this part twice, and then it goes through this and they will rearrange this. So it's linear, but it's traversing twice. So it's still linear in total. And for space, we are also using extra, the output will be needing all the characters and the words, so it is linear in space as well. We are building this result and we are storing them in lists. Yes, so linear time and space, that's really good. Alright, let's look at the other solutions. I'm so hungry. I will go over this quickly and I will eat. Okay. Okay. A lot of functions, but yes, exact same idea, different implementation. All right. Okay. me a Python solution. Let's see. List 0 for all the words. Okay, I'll need more time to read this since this is more cryptic. Current. Wondering what this current is. Okay, current is incrementing the length of all words. Okay, so the length of all words plus minus 1. Length of words plus white space. Okay, minus that. I in range max with max number of letters. Okay, I will need more time to look at this, but I'm too hungry right now. So okay, interesting. Alright, so I will conclude my video here for this problem. I'm just happy that I managed to solve a hard problem, even though it takes over an hour. So hopefully it will improve and eventually I can solve a hard problem within an hour. I guess that's the goal. Alright, I hope this is helpful, and let me know if you have any questions or any requests for any specific problems. I will see you in the next one. Have a great day and weekend. Yes. Bye.